The aim of today's investigation is to determine which type of car proves the most cost effective and has the most positive impact on the environment overall. To help us solve the problem, we'll use the strategy of acting it out as identified in Pollier's classic four-stage model. In this process, we'll use the character Nathan as our example. To begin the investigation, we need to determine the following information. The key mathematical concepts we will explore are addition, subtraction, multiplication, and division. By implementing these concepts, we will be able to accurately solve our problem. Let's first take a look at exactly how many kilometres per week, or Ks, Nathan drives his petrol car. Between Monday and Friday, Nathan travels 5 Ks to work and 5 Ks home from work, giving him a total of 10 Ks travelled per day. On Saturdays, Nathan likes to spend time at the beach. To get to the beach, he travels 50 Ks to get there and 50 Ks to get back home, totaling 100 Ks for that day. On Sundays, Nathan likes to stay at home and rest. He does not drive that day. So in total, per week, Nathan travels 150 Ks in his car. We will now take a look at how much money Nathan spends on petrol per week. On average, his car uses 10 litres of petrol to travel 100 Ks. With petrol costing $1.25 per litre, it costs Nathan a total of $18.75 per week to drive his car. Due to the fact his car requires petrol to run, it also releases harmful gases into the atmosphere. On average, 1 litre of petrol used will produce 68 litres of carbon dioxide. So by using 15 litres of petrol per week, Nathan's car is releasing up to 1,020 litres of carbon dioxide into the atmosphere. We will now take a look at the costs associated with driving an electric-powered car, starting at how much they cost to charge. To travel 100 Ks, it takes 18 kilowatt hours, or kWh, of power, with the cost being 25 cents per kWh. So in total, it will cost $4.50 to travel 100 Ks in an electric-powered car. In regards to the release of harmful gases into the atmosphere, electric-powered vehicles do not release any. Now that we have determined the financial and environmental costs associated with petrol and electric cars, we can evaluate how we came up with these figures and determine which one is most environmentally and cost effective. This graph shows us the number of Ks travelled per week in Nathan's petrol car, showing a consistent number of Ks travelled during weekdays, with a significant increase on a Saturday. Let's now go through the various steps to calculate how we determine the number of Ks Nathan travels per week. Firstly, we'll take a look at how far Nathan travels per day, between Monday and Friday. According to the graph, Nathan travels 5 Ks twice per day, so in order to determine the total distance he travels per day, we multiply the 5 Ks travelled by 2 trips, which will equal 10 Ks travelled per day. We will then multiply this number by the amount of times per week Nathan travels 10 Ks, which according to the graph is 5 times, which gives us a total of 50 Ks travelled during that portion of the week. Lastly, we will calculate the distance travelled over the weekend, which according to the graph is 100 Ks, 50 Ks to get to the beach and 50 Ks to get back home. To determine this figure, we simply multiply 50 Ks by 2 trips, which gives us a total of 100 Ks for that day. Now according to the graph, Nathan does not drive his car on Sundays, so we can now begin calculating the overall weekly total. To do this, we simply add the 50 Ks Nathan travels between Monday and Friday to the 100 Ks he travels on Saturday, which gives us a total of 150 Ks travelled for the week. Now that we have determined the overall distance travelled per week, we will begin to calculate the overall weekly cost of petrol. As we discussed earlier, Nathan's car uses 10 litres of petrol to travel 100 Ks, and on average petrol costs $1.25 per litre. So to calculate the total cost of petrol per week, we first need to determine how many litres of petrol Nathan is using for the week. If he is travelling 150 Ks per week, that would in fact mean that he is using 15 litres of petrol per week. In order to calculate this figure, we must look at the amount of petrol used per 100 Ks. We can see that Nathan's car uses 10 litres of petrol per 100 Ks, so we start by writing down the figure 10. To determine the figure, in which we will add to our initial 10 litres, we must divide 10 litres of petrol, as we know Nathan uses this amount to travel 100 Ks, by 2, as this is the equivalent of half of 100 Ks, or 50, which gives us 5 litres of petrol. We will then add our 10 litres to our additional 5 litres, which gives us a total of 15 litres used per week. Now that we have determined how many litres of petrol per week Nathan is using, we can determine his overall weekly cost of petrol. With petrol costing $1.25 per litre, and Nathan using an average of 15 litres per week, we must multiply the 15 litres per week by $1.25. This tells us he spends $18.75 per week on petrol. We will now determine the environmental costs associated with Nathan driving a petrol car. As we discussed earlier, on average 1 litre of petrol will produce 68 litres of carbon dioxide. So by using 15 litres of petrol per week, his petrol car is emitting up to 1,020 litres of carbon dioxide into the atmosphere. In order to determine this figure, we must multiply the amount of petrol he uses per week by the litres of carbon dioxide released into the atmosphere. As previously determined, we know Nathan generally uses 15 litres of petrol per week. So when we multiply this figure by 68, we can now see that on average per week his car is releasing 1,020 litres of carbon dioxide. We will now take a look at the weekly cost of driving an electric powered car. As previously determined, we know that to travel 100 k's it takes 18 kWh of power, with the cost being 25 cents per kWh. With Nathan driving 150 k's per week, we need to determine how many kWh of power this will cost. In order to do this, we must use our previous knowledge that to travel 100 k's in an electric powered car, it takes 18 kWh. So to determine how many kWh of power it would cost to travel 150 k's per week, we first divide 18 kWh by 2, which will give us 9 kWh. We will then add this to the 18 kWh that we know will be used to travel 100 k's, which will give us a total of 27 kWh of power required to travel 150 k's. We must now determine how much this will cost per week. With the knowledge that each kWh of power used costs 25 cents, we must multiply this number by the 27 kWh used, which will give us a total cost of just $6.75 per week, proving $12 cheaper than petrol, as we know that the weekly cost of petrol is $18.75. To determine this difference, we simply subtract the $6.75 associated with using an electric car from the $18.75 of weekly petrol costs, relating in a total saving of $12 per week. As previously identified, we know that in driving an electric-powered car, 0 toxic gases are released into the atmosphere. In comparison to the 1,020 litres of carbon dioxide immersed into the atmosphere per week by driving a petrol car, the electric-powered car proves to be the most environmentally friendly overall. In conclusion, with the implementation of various mathematical computations, our findings have determined that it would be more environmentally friendly and cost-effective for Nathan to travel in an electric-powered car as opposed to his petrol-powered car. This proves evident as we can now look back and examine our solution whilst checking our answers with our calculators.